Alright, so printing hello world 5 times is super easy. All we have to do is, I'm just going to erase all this. Okay. We just make a loop. And we say go. And there we go. That will print hello world 5 times with the 5 go routines. Okay, so these are all sort of running at the same time. It's not printing hello world, hello world, hello world. It's like all 5 in the start, and there you go. Okay, so that's really easy, not super interesting. I just wanted to get used to typing go to do things. For ping pong, the idea here was it's sort of like a pipeline of ping, and then something replies with pong, and then we eventually read pong. So there's a bunch of ways we could do this. We're going to need, I'll show you some of them. So we'll have, say, 2 channels. We'll have C1 and C2 string. And we can start a function. I'll go ahead and name them so you can see their names. And what he's going to do is take in a channel, and all he does is write ping to that channel. So, and then we'll have another one, ponger, and he has 2 arguments, so he'll have 2 channels. And what he does is he gets a message from the first channel, and then he writes pong to the second channel. Okay. And actually, we don't use the message, so I'm just going to discard it. And then, so we start the pinger, we start the ponger, and then we're going to start a printer that will read from the second channel and print it out. Okay. Following the code so far? So there's 2 channels here. I send the ping, I receive the ping here, discard it, and then I send pong, and then this guy reads the channel and prints it out. So this should print pong, theoretically.
You received ping in that pong, or did you?
Yeah, I mean, I can show you.
Can you go to post-app when it's done up to scratch, please?
The one in scratch is I put a loop together, so I only had 2 go functions, and they would print the message and then send ping. All right, he would send ping, print the message, and then receive pong, so that they would ping pong back and forth.
Yeah, you could do that too. Yeah, you could do that. I mean, I just wanted to give you guys using channels, okay?
I'm confused by the channel, like the channel. It seems like you could just be doing this one without a channel, right?
Sure. I mean, you can do most of these programs without channels.
Yeah, but what's the channel, like, where's the channel coming in here?
It's allowing us to, we have 3 separate tasks all running simultaneously. It allows us to synchronize them. So it makes it so that printing pong, I can guarantee that this code happens before I print pong, and I can guarantee that this code has happened before I print pong. And the reason why is because this happens after this happens, right? Because these have to happen simultaneously. And this happens after this happens because these are coordinated, right? They're synchronized. So I know that this will always print pong or got, and then ping, and then it will print pong. But these are 3 separate things happening at the same time. So it allows us to synchronize concurrent things. Okay? Still not understanding?
Well, what makes you know that they're gonna go in that order? Or is it the way you call them, the channels?
Yeah, it's the channel, remember it's synchronized, so you can only send out a channel when something else is already receiving from it. So I can sort of guarantee that that's going to happen.
Whoever gets the channel first is going to wait until the other one gets there.
Okay.
Yeah. We could do many variations of this. For example, we don't have to have a printer. I can just say, right, I can just print here, because this is another place I can print. So that would be one thing we can get rid of. We can also get rid of the middle guy. I can say, do the same thing I'm doing here, right inside of here, okay? And now I've started a pinger, and I'm going to pull off the channel and put on the other channel. Unfortunately, this program has an issue. This needs to happen before. If I don't do that, it blocks up, and this can never happen because nothing ever reads from C2. But if I do that first, then it does, okay?
And they don't have to, you could printer before you pan, right?
Yes, the order here doesn't matter. And in fact, the way it was before, you're not guaranteed that pinger starts before printer. Because this go routine, it like immediately says go start and then finishes, but it might be, you know, go to the stack and all this other stuff. It doesn't necessarily go to immediately to the next instruction. It might wait right before the next instruction for a little bit. And so the order here, once you see this go, when does the coding here happen? Well, you know it doesn't happen before here, but you don't know when it happens down here. It could happen at this point, this, you know. Once you've done that, you don't know when it happens, okay? That's why the order doesn't matter so much for these guys, which is another nice thing. Capability, and we could also replace pinger with this code to go on pinger. As for the example of, you know, I want them to ping pong back and forth, so we could do that, right? I could say in a loop.
You might want to put a delay in so it doesn't go in quick.
That's right. That's a good point. Though if we want to see that, that's fun. So I want to send the message on the channel, and we're saying printing. Actually, we want to receive, don't we? Yeah, so I want to do this, and I want to send ping, and this guy's going to be exactly the same, except he's going to send pong, right?
You might want to, I think that you want to switch the ping with the message receiving, because it won't send the ping until it receives the message.
That's
and
right.
The other one won't send the message until it receives ping.
Yep. So this is going to lock up. Okay, right, we should expect that to do nothing, because they're both going to lock up. It might say deadlock, right? That's my way to put it into. It might just sit there forever. Okay. So that's no good. We can start it, though, by doing something like this. Oh, yeah, now it's going. Ping pong, ping pong, ping pong. Okay, everybody following? I had to start it because they're both starting out by receiving. Okay? And they both sending. So I started, and once I started, one of them starts, either pong or ping. And then they go back and forth after that. Okay? Though in this case, because we're using one channel, pong can come back to himself. You can end up with pong pong. Or ping ping, or whatever. So that's no good, but just saying that is possible. Anyway. I guess actually you can't do that, can you? Never mind, I take it back. It has to be ping pong. Because this doesn't finish until somebody pulls off of it, Yeah, never mind. It's always ping pong, ping pong, ping pong. Okay.
It's kind of hard to wrap your head around a little bit. Like, where does the baton passing occur? Where is the one thing waiting?
In the channel.
It's, yeah. So there are more examples. I need to show you select. So there's a special statement, select. And the way select works is it allows you to select from multiple channels. This should look familiar. So select is like a switch statement for channels, okay? But it's select, not switch. But the case looks very similar, okay? So the way the select works is the first one available will be selected. If there is more than one available, it will randomly choose one. But the first one available will be selected, okay?
You said select is like a what for channels?
Switch.
A switch. It looks just like a switch statement. So I'm just going to print these. Oh yeah, I got to make two of them. And then we're going to have to kick off something to write to them. So
Is there an easier way to make the channels? Like how maps have got the shorthand with the curly braces?
no,
and
there's
such?
no shorthand for the channels. So we'll call this writer1. Let's call it writer actually. And we'll give it a message string and it'll write it to the channel we give it. So forever. And now I'll just start two writers. And we'll say writer number 1. Okay, so now I started two writers. They're going to write to the channel. And this one select statement will pick the first message available, okay? And it just got the one because I only selected one time. So it got message 1, writer 1. I'll add some delay so that we can maybe see something. So time let's sleep. Rand int n. Incidentally, that's how you make a random number. Use rand, the rand package. Int n means integer from 0 to this number. I don't think it includes that number though. No millisecond. I want to wait 100 seconds. It'd take forever. Okay, let's try that. Stop. Okay.
You need to see the random number generator.
No, I shouldn't need to. This isn't, it's always getting the first one for some reason. Did I mistype something here? No? Let's do it in a form. So now it's going to print messages for forever here. There we go. It's randomly getting messages. Notice now they're not like 1, 2, 1, 2, 1, 2, 1, 2, because the amount of time they're waiting is different. So I have one process, one task here, one go routine that is taking these messages, and it's reading both of the channels, okay? So if you need to read multiple channels, you use the select statement, and it will always pick the first one available, okay? So one very common pattern is if you want to do a timeout, you can say time.after. And receive on it. Okay. And the way this works is that there's a special function in time, the package in time, that after the amount of time you give it, it will send on this channel the current time. So if neither of these happens within 1 second, this code happens, because I will get a value on this channel. Okay. So if I increase this, make this take multiple, I make it take a longer, we should be able to get the timeout, okay? See that? Does it make sense why it's not always timing out?
I think it's going to take me a while to fully understand this.
So,
I get the basic concept, right? Like we have concurrency, which means we have multiple threads running at the same time. And those different tasks sometimes need to coordinate since they're asynchronous, they're just running independently. And so to connect them, we kind of do a little connector called a channel. And that allows one to have to wait until the other one passes through a little message and says, okay, this is the point. And then when the other one gets that, it can start going again. Like I understand that, but like actually kind of like tracking it in the code here with my head and like seeing where the waiting is occurring. And even kind of in some ways showing waiting is random. I'm not seeing that totally, but I get the theory.
okay, so the select statement, what it does is it gets here and it will do the first case that can happen. So this case can't happen for 1 second. It says after 1 second, it'll send the time on this channel. So this creates a channel, time.after creates a channel. And then we immediately receive from it. And this case happens after 1 second. Okay? These cases happen some random amount of time. It's 1 second plus some random, up to 100 milliseconds. So they take between 1 second and 1 second and 100 milliseconds, so 1.1 seconds. Which one happens, if it happens, depends on that random amount of time. Right? But the first one will always happen. Okay? So if this happens before these, this one happens. Okay? So you use the select like this to do that, to get this. This is very common pattern is this time. Okay? Because you're like, go run something with the go command, right, with the go keyword. But you're like, well, what if it takes too long? And then you can use the time.after. Okay.
You want to put that up on Scratch? Thank you.
Okay. So that's a select. There's also a default. Anybody guess what default does in a select? Because we have default in the switch. Remember what default does in the switch?
It's like else.
Yeah, it's like else. It does it if none of the other things match. So it works exactly the same way with select. If none of these cases happen, the default happens. This means that unless something is already waiting on one of these, default happens. Okay? So this select statement always happens like immediately. Because, like I said, unless there's a message waiting, we go to default. So let's print that and we'll see what happens. I expect we'll see a whole lot of defaults. Okay? And then every second or so we might see a timeout, and then every second or so we might see one of these. Though actually we'll probably never see timeouts, because this is a new timeout every time. So maybe I should bring that out.
Can you explain your you're kind of projecting
rejections?
Yeah, just how did you,
Yeah. So remember, the default happens no matter what. If none of the others happen, the default happens. Okay. So since these only push a message every second or so, this loop is going to loop around. There's nothing available, print default. Loop around, nothing available, print default. Loop around. So default's going to happen a whole lot, right? It's going to go as fast as the computer can push out default. And then every once in a while, it'll say got message 1 or got message 2. Like every second or so, it might print one of those. I was saying the timeout might happen, but actually, because of the way this is written, the timeout never really happens. Because this is like creating a new timeout each time. There's no way it ever takes a second because this always at least happens. So it's never going to wait for this. It's always going to immediately finish. So what I was saying is I could bring this out, and then it might happen. Okay.
and the got message 1 and 2 are just random in terms of when they'll happen?
Yeah, they're random because I'm literally doing random up here, random integer. So let's pull that out. So we're going to call that timeout. Oops. Okay, so now this timeout happens outside of the loop. So after 1 second, no matter how many times this loops around, it'll get you. Okay. So let's see what that does. Whole lot of defaults. Maybe we'll see something that's not default. Doesn't seem like it's going to happen. Default's just taking over. So maybe that's not that surprising.
Grab the code off the scratch.
There's nothing on Scratch.
I thought I just put it up there. There. Took out all the times from that.
Okay.
Mine would show some.
Missing something. Yeah. Anyway. Oh, there's one. The point is that default's happening too much to really have this work effectively.
I think this computer is so fast that when it prints the other messages, it's going off screen too fast for you guys to
Something
see.
like that.
Yeah.
Anyway, we occasionally got a message, but all I wanted to say was the default, it happens immediately. So if you want code that doesn't block, in other words, code that doesn't just wait until one of those channels happens, you can use the default.
If you skip default, we'll select wait.
Select will wait until one of those channels happens.
If you skip default.
We can try that.
Try it.
Just run it without the default.
Yeah, you'll get got message 1 or got message 2.
It's gonna go a lot slower.
Now it'll go fast, there's no times there. It'll never be something like that.
Right, so you have cases when you need to do channel selection, you do it with the select. You can also send on channels. So I'll show you that. We can sort of collapse all of this logic into one for loop with the selects, okay? And the way we can do that is I have these 2 channels. I can say case and then send what did I call it? Writer 1. Case. And this is going to actually deadlock, but I think. Yeah, because there's nothing on the other end. So we need at least one other go routine. But we can collapse the writer here to do that. There. Now we have a writer and a reader. So what I did here is we have 2 channels, and now I'm going to send in the select. You can do that too. Okay. So you can receive and you can send. Okay. So if C1, if we're locked in here, it might send C1. If we're locked in here, it sends C2. So these two things are going to be synchronized like that, right?
Will it choose from message? Will it choose from the sending and choose from the receiving?
So, yeah, it tries to be fair about it, but if they're both waiting, but yeah. Does this make sense? What I'm trying to do here?
When you have it sending randomly from to channel 1 or channel 2, when it's receiving, will it ever wait for the second channel because that's the one it chose to select if one's already in there? Like let's say it chose to select channel 1 to send to channel 1, right?
So it's like,
And then it chose to chose to receive from channel 2, message 2, but it's channel 1's full and message 2 is waiting to receive.
yeah, so they're always full, right? There's no concept of empty or full because they're synchronized. So you can't put something in and go do something else. You have to wait until somebody's on the other end to get it. So we have these two sync points, right? And what I'm saying with writer is, so we have the writer task up here. He can write to either of them, and he's going to wait until either one of them is available. And then we have reader over here, and he's waiting for either one, okay? So if this one becomes available first, then that's what they'll both do, or that one, I mean, it can go either way. It's sort of random because the select is going to try to choose it equally. But
Select's not choosing randomly, select's choosing whichever one's in use.
Okay.
yeah, so let me add a step to this so we can see. Well, this is why I have these delays in there. Otherwise, the behavior is just, it doesn't mean anything. This only makes sense when you're doing something that does work. Okay? So we can add to this, if we do instead, we do C1 and have another thing that reads it. Okay, and we're going to flip a coin. I guess it's 2. So if that's 0, then we'll send it on C2, let's say. Actually, I'll just get rid of this. Otherwise, we'll send it on C1, okay? So we'll say heads and tails or something. So, I mean, this is the code I wrote in the first place. So, but the point is you can use select to select from multiple channels. So I can have one printer that selects from all the channels, right? And so this is like always getting tails, and this is always getting heads. But you can have one task that is receiving from all the channels. I don't have to have multiple tasks to do that, okay? And so if you have multiple channels and you want to pick the first one, use the select. Okay, so a wait group. A wait group is a super common pattern.
Is that something you apply to classes after lunch?
Huh?
Wait.